Hello everyone! Today we are going to learn about one of the most important and widely used keywords in Java, which is the static keyword. So by the end of this video, you will understand exactly what static means, where you can use it, when memory gets allocated for static variables, and the key difference between static and instance variables. So the static keyword in Java makes a variable, method, or block independent of objects. The static keyword in Java makes a variable, method, or block independent of objects. Let me explain what that means. Normally, when you create a variable inside a class, each object gets its own separate copy of that variable. If you have two objects, object 1 and object 2, each one has its own version of that variable with its own value. But when you make a variable as static, there is only one copy of that variable shared by all objects of the class. Think of it like a shared whiteboard in a classroom. Every student in the class can see and use the same whiteboard. It does not belong to any student, it belongs to the class itself. That is exactly what a static variable is. It belongs to the class, not to any specific object. For example, static int can equal 0. Now let's talk about something really interesting. When exactly does a static variable get its memory? To understand this, let's talk about what happens when you run a Java program. So, let's go step by step. Step 1. So, in step 1, you write your code and compile it. The computer produces a dot class file, the bytecode one, right? We have already talked about it in previous videos. In step 2, when you run the program, the JVM class loader loads the dot class file into memory. The JVM loader loads the dot class file into memory. In step 3, when you run the program, during this step 3, this class load process, something really important happened. All static variables are initialized and static blocks are executed right here before any object is even created. Before objects. And in step 4, since static variables get their memory during class loading, they exist before any object is created. This is exactly why they are independent of objects. They do not need an object to exist. This is a fundamental reason why static variables are shared. There is only one copy, created once during class loading, and shared by every object that is later created. Now let's see the difference between static and instance variables in actual code. So first let me write a few variables. The first one is static variable. Name is DA equal 100, and it is an static variable. To make our code much more readable, I will remove this one. And now let's write an instance variable. Int in b equal 100 semicolon, and it is instance variable. Let me remove this text as well to make our code more readable and clean. So now let's create two objects. How we can create objects? First I will copy the name of the class, write it, then I choose a name for our reference variable, for example, object1 equal new keyword, again the name of the class, parentheses, and semicolon. The second object can be created in the same way. I just change the name. Now let's access static variable. So let's first use the class name. What is the name of the class? Student dot.sta. Using class name. Let me run the program. Yeah, by the help of the name of the class, I could access the value of static variable. Now let me use object name. Object1 dot stay. Let me run the program. Yeah, again 100. This time I used object using object name. So now let's access the instance variable. First, I use the name of the object dot int b using object name. Let me run the program. Yeah, we have 3 values, right? 3 outcomes. Now let's use the name of the class. What is the name of the class? Student dot int nb. Using the name of class. Let me run the program. It shows an error because we cannot access an instance variable with class name. So this is the first difference that we notice here. So the static variable sta can be accessed using both class name and the object name. But an instance variable can only access using object. Trying to access it with the class name gives an error. Now let's see what happens when we change the values. Let me write them here, like object1 dot nb equal 500, object1 dot sta equal 999. So let's access static variable in the same way. Let me first write a comment here for a static variable. We use both object. Let me copy and paste it here, and this time I use object2. Right, we have created 2 objects here, object1 and object2. Let me run the program. Okay, before doing so, first let me just make our code more readable. Just put this and run again. So for this part, for both object1 and object2, we have 999, both chained, right? Let me write it here, both chained. Now let me go for the instance variable. I use the same method. I just copy and paste it here. Here I change the name of the variable in B. Now let me run the program. Okay, we see that for object1, the value has been changed, but for the object2, the value which we had at the beginning has not been changed. So the value that we had at the beginning was 100, but here we see it has not been changed. So let me write it here. Object T unchanged. This perfectly shows the difference. When we change STA through object 1, object 2 also shows the new value because there is only one copy of STA shared by both objects. But when we change NB variable through object 1, object 2 still has its original value of 100 because each object has its own separate copy of NB. So before we finish, let me quickly go over two really important rules about static. Rule number 1, inside the static method or block, you can access static variables and method directly without creating an object. So right now we are in main method. Look, we are inside main method. So I want to print the value of STA without writing the name of the class or object. Yeah, we can see we have the value 999. So to make it more clear and clean for this section again, I put this to see the value and the outcome of this part. Yeah, 999 without using object name or the class name. So works fine, static accessing static. So rule number 2, inside the static method or block, you cannot directly access non-static variables or method without creating an object first. So for example, let me go for int nb. Now let me run the program. Yeah, we see that there is an error. We cannot make a static reference to a non-static variable. So to access NB inside a static method, you must first create an object. So this is the static variables in Java. If you enjoyed this video, make sure to subscribe the channel so you never miss a video. See you in the next one.